build system. Hi, I'm Peter. I come from Denmark, and I live in the beautiful city of Copenhagen, where I am the organizer of Copenhagen.js, our local JavaScript meetup group. I work at a company called Podio, where I'm the front-end lead developer. So that's enough about me. That's not what the talk is about. It is about the no-build system, which is a pretty weird idea. It's something that came to me when I was thinking yet again, which I've been doing for many years, about the development lifecycle and how a workflow, our daily workflow, works. So let's take a bit of a look at that. Our development lifecycle consists, or in the 90s at least in the golden days of web development, it consisted basically just of a development iteration. This is where you would think of an idea, you would put it down in your editor, you would look at it in your browser, and you would have a big question mark over your head because your browser wouldn't tell you anything about how the internal workings were. So in the 90s, we were all reverse engineering how to make things look the same in all the browsers. So you spend a lot of time figuring things out, and you had iterations upon iterations to try to make things look well. And at the end of that, we probably did a deployment with FTP, yay. So in modern days, people have thought a bit more about the development lifecycle, and people have identified different other phases that are critical to the lifecycle. One of those phases is boilerplating or bootstrapping your application. You have projects like HTML5 boilerplate, which gives you a ready-to-go index file that you can start your application with or your website. You have projects like Yeoman that can scaffold out entire apps for you. You will probably have a step where you do some package managing, where you configure your Bower or your NPM to download all your tools, so you don't have to do that manually and take care of all the versioning manually. You still have your development iteration. It looks a bit different. I'll get back to that later. And before your deployment step, we have a new step, which is the build and optimization step, and I'll also get back to that in a second. It's important to look at some of the characteristics of these individual steps in the development lifecycle. Mainly the one difference between all of them is that the development iteration is special because that is where all your manual work basically applies. All of the other steps are completely automatable or should be automatable down to the point of a single click of a button. I wish you could do that for development iteration, but then again, I wouldn't have a job. So the development iteration is the thing you want to focus on, the thing you want to keep lean and fast. So let's dive into that a bit. If you think of a development iteration, if you think of it as the road you take from conceiving an idea to trying to realize and get feedback from the browser or from your tools on how that idea is perceived, then that would be a round trip in your loop. So you conceive of your idea, you write it down in your editor, you might have some authoring abstractions like Sass or less or CoffeeScript that need to be compiled. You will probably live reload your browser because that's faster than doing it manually. You will use your developer tools in your browser to inspect stuff and to look at how things are. You might even change some values in your browser, and you might have set up things like emit lifestyles to synchronize these changes back to your editor. So these tools are helping you having a much faster development iteration, which means that you can spend more time figuring out what you actually want to do and how to actually implement it. So these tools all help you getting a lean development loop, a fast development loop, something that is simple and intuitive. If anybody has seen the talk by Brett Victor, Inventing on Principle, that is what the development loop is all about. It is about getting the sense of immediacy, that when you have an idea, you see the result of your idea, and you get a sort of intuition on how things work. That is how you learn the best. So then there is the build and optimization step, and that is what I will call the build system from now on. It is all about the web performance. So, oh, that's interesting. There we go. So why do we even need a build system? Steve Souders is probably the main man here who has put in a lot of work at Yahoo back then to figure out why we need to compress our stuff and why we need to do certain things to our code in order to send them over the internet very quickly. So the reason we need a build system is all about transport. There are specifically two details about transport that are important. It's bandwidth and it's latency. To mitigate the problem of too little bandwidth is why we compress our assets. To mitigate the problem of latency is why we bundle our assets and make them into as few files as possible. Those are basically the two things that affect our transport. And that is why we need an optimization step before we go to deployment, because I think Alex said it at Front-End OpsConf that if you want to make a good user experience, you have to build it on the base of web performance. So you need to get performance first before you can even give a good user experience. So let's take a look at your development code. It is a beautiful unicorn. You have crafted this code. It is split up into a lot of different files. You have a beautiful architecture. It's readable, it's commented, it's testable. You can easily explain your junior what's happening, and that is your unicorn of a development code. Then your build system comes in and makes it into something completely different. This is your production code. This is not something you should show your juniors to try to teach them JavaScript. It's something that you don't want to touch as a human. So you have your development code, which is definitely not equal to your production code. They have completely dissimilar properties. Your development code is human readable, and your production code is machine readable. So that's important to keep in mind for later. So the no build system is about not dealing with the build system in your development step. You don't want all the complexities of compression, of bundling, of all of those things in your development loop, because they add to the complexity. If you have bundling in your development loop, you will need a different tool to offset that bundling. You will need things like source maps, which adds yet another tool to your chain, yet another abstraction which you have to deal with to try and figure out what actually happened to your code. Let's take a look at some of the automation that is out there currently. I think the probably most commonly used tool is Grunt. Who in the audience is using Grunt? That is a lot of people. That's about half. Okay. So Grunt is not a build system by itself. It is a task runner, and you can combine tasks to create a build system. So a task in Grunt looks pretty much like this. You have some input, you do something to it, you get some output. Your input would be a configuration of a list of files that you want to work on. Your task would probably be a grunt wrapper for some Unixy tool that does one thing and does it well, and you would have an output. And you can have several of these after each other, and that basically builds or makes your build system. And you bind these together with configuration. In Grunt, you have a lot of configuration because you basically have to configure your input and your output for each individual task. So it's not uncommon to see grunt files that are 600 lines plus. I would usually do a vote here to see how many lines of code your grunt files actually are, but I mean, the Yeoman default scaffolding is around 550 or 600 lines. It is not simple. That is one of the reasons why Gulp came along. Gulp tries to take a different approach towards the configuration part and how to run tasks. So what Gulp does is it takes your input files, it puts them into a task, and it pipes the output of that task into the next task, and into the next task, and at some point you reach your last task, and then it writes the output to disk. So you have less file I/O. That's one of the things that makes Grunt slow, as well as having big configuration files. So this means that Grunt has less configuration. It is declarative. And it also means that, that things are a lot faster because you have less file I/O. So what Gulp wants you to do is try to identify files that have similar properties, like all your CSS files and all your JavaScript files, and define pipes for each of those, and you can run these in parallel and get your output. That's very, very quick. Both of these join a historical set of tools that are quite similar. You have all of these different task runner tools from Linux and from Unix and back in the days, which basically do the same thing. They wrap Unix tools in an easy way. They've tried to establish some context around these tools that only know how to deal with one thing. So we join the leagues of Make and Jake, Rake and Maven and the ton of other task runners that are out there, basically. There is a big problem with all of these, though. The problem is that they are all treating all of your files as individual files out of context. And that is actually not true for a website. A website is different. We are different from everybody else. A website can be described as a dependency graph. It is not a list of files that you can work on. It is not a stream of files. It is not even a tree of files. It is actually a completely multi-relational dependency graph. You can have cyclical dependencies, you can have anything. That doesn't fit well with the paradigm of just working with files and trying to figure out a list of files. So what we're doing here is that we're using tools that they're simply not up to the challenge of doing the build of a website. The reason this works for a lot of other programming languages is that they have very strong conventions that say if you build a file, it has to be exactly here, and the module loader knows how to find it, and they don't have to deal with the concept of transport. So they don't have to do all the ugliness of bundling files together. If they do, they probably package it up as a single zip file, which you then can unpack completely at the other end. So the first problem with not treating a dependency graph, which a website is, as a dependency graph, is discovery. You basically have to configure your build system to take this list of files and do something to them. And what you're actually doing here is you're writing a manifest. You are duplicating information that is already available in your source code. Because if you think about it, your browser already knew how to read that website and how to load all of the different files that it's actually using. But here you are writing a list of files that is a complete copy of all the files that are in your source code. But what you're doing is you're applying your knowledge of the dependencies and flattening it out as a list. That's not maintainable, because when your junior suddenly needs to add a new library and adds it at the wrong place in the list, your dependencies go wrong and you get a JavaScript error. The second problem is coherence. So at the beginning, you have a dependency graph, your website. It might have an HTML file that points at two JavaScript files. What comes out is a bundled JavaScript file, and suddenly you have an HTML file that points at two JavaScript files that are no longer existing. They actually both have to point at the new bundle. Since these tools have no concept of the rest of the context, what you get is an incoherent dependency graph. And it's left up as an exercise to the implementer how to figure that out. And how people usually solve this is by leaking details of the transport build into their development step. What happens is that all of these things that you shouldn't be thinking about, that you shouldn't have as abstractions in your development build, leak slowly into your development loop. So you have file renaming in development, you have bundling, you have spriting, you have compression, you have all of these things that you shouldn't have in order to get a sense of immediacy, in order to get an intuition about your files. And I'm picking specifically here on SAS because it actually by default does bundling if you're using the add include statement. Then you're basically bundling together all your CSS instead of doing individual includes where they're actually needed. So it seems that there's a piece missing to this puzzle. There is some tool that we don't have that might be able to make all this simpler. And that's what I've been thinking about. It started a long time ago at a company I worked at for 5 years ago. So we sat down, me and a colleague, and the state of the art back then was that Node didn't exist. The best built-in system there was I think it was Yahoo Builder. You had a bunch of XML that defined your manifest, basically similar to Grunt. And what we came up with was that we have to use the source. We have to make our build system somehow know about this dependency graph by itself, just like the browser already does. So our build system has to treat your code like the browser would. And the idea we came up with was AssetGraph. AssetGraph is, again, not a build system. We wanted a build system, but we came up with this abstraction along the way because we really needed it, we figured out. So what AssetGraph is a data model that tries to describe the entirety of your website in one go. It is an attempt to read all of the context and keep it alive at the same time. This means that you read in your entire website and keep it in memory. Each asset is represented with a data model that is corresponding to the file type. So you would have your HTML instantiated as a DOM tree. You would have your JavaScript instantiated as a JavaScript syntax tree. And the graph is able to actually traverse these and do a static analysis and figure out all of the outgoing relations. This solves the problem of discovery, because what you can do with this is you can actually tell AssetGraph, this is my index.html file. Please go and automatically discover all the outgoing relations of this, and do this recursively until there are no more outgoing relations left. It's basically a scraper. It will navigate your entire website and build a model of it in memory. This reduces your configuration of your input files down to one, index.html. Well, you might also point it at your error pages, which you usually don't link to, so it can find it automatically. It solves the problem of coherence, because it gives you a bunch of graph methods, and if you use these methods to move files around, all it is actually just a renaming, and because it knows about all the incoming relations to this file, it can update all of them wherever they start out. So if you have a source attribute in a script tag to a file that is renamed, that source attribute will automatically be updated to the new location. We've built a ton of different transforms, which we call them, which are basically your tasks. They are things that apply changes to your graph, and they keep the coherence between each step. So what you get is a website in, and you get a website out, and that's a part of the guarantee that we can give you by treating things like a graph. So a build system with AssetGraph looks pretty much like this. It takes an AssetGraph in, it applies a number of transforms, and you get an AssetGraph out. And then you simply call the serialization method on the graph, which gives you your website as files on disk again. So it has similar runtime properties as Gulp has, because it's working all in memory. It's not streaming in the same way, so it's a bit slower. But there are options for parallelization which can be figured out. So that's all theoretical. Let's take a look at how we can actually use this in practice. So there are two approaches. The first one is the most difficult one, do it yourself. AssetGraph is a tool maker's toolbox. It is extremely abstract. And I would say don't venture into this territory unless you know a lot of Node, and unless you are willing to dive into a new paradigm, because this does not really feel like working with files anymore, because you have to think about relations and cyclical relations and files all the time. It is a bit difficult because we're actually not at the point where the documentation is good enough. At least we're not happy with it yet. It's a work in progress, but I would love feedback if anybody is interested in going in and read some of the documentation and give us feedback on it. So that sounds a bit discouraging, I know that, because you might want to have some tool that you could just pull off the shelf and just use right away. But despair not, we actually have that, because we wouldn't have built this without actually building something that we could use it for. I mean, we were scratching an itch at the time. So you can use our existing tools. So we have a tool that we call AssetGraph Builder, very original, which is our very opinionated look at how you should optimally build single-page web applications. That's basically our target. You can also build multi-page web applications with it. It has a grunt wrapper, so all of you guys running grunt, you can just run grunt reduce instead, which also takes a very minimal configuration and basically does all the work for you by automation. So this is all fine and good, and we have this running in production internally in the company, but making people aware of it and actually proving that it delivers on the promise of not having to configure anything and it just works out of the box like a browser would, we had to do something. We had to prove that it's actually a viable approach. So I talked to the Taste.js guys and talked specifically about the TodoMVC project, which is basically a big list of similar applications. They implement the same application in a lot of different frameworks, which means that this is code that is written with no build system in mind at all. It is written for a lot of different frameworks, and it has a lot of different coding styles. So this is basically a collection of examples of code you would see in the wild. So I talked to Adi Osmani on the IRC channel, and this is probably too small for you to read, so I'll just read it out. I told him I was thinking of building all the TodoMVC applications with it being AssetGraph builder just as a demo. And he's apparently laughing out loud and saying, if you're able to do anything with all the TodoMVCs, I'm impressed. Even a few is something. And I thought, he didn't say it's a challenge, but I took it anyway. So I created the project, which is called the TodoMVC Challenge. The idea behind it is that I have to take all of the TodoMVC applications, apply the build system without any changes to the code, and the output has to be functional. And that's basically a test of whether the build system is good enough that you can take it and use it out of the box without you thinking of a build system during your development step. Get back, there we go. So the first iteration of the TodoMVC challenge took quite a while. I think there were 60-odd applications at the time, but the first iteration actually yielded pretty good results. At least I was happy with it. I got a 40% success rate. That means 40% of all the TodoMVC applications available actually built out of the box with zero configuration other than just pointing it at the index file. I think that's quite impressive. That was 4 months ago, and we've been iterating over bugs. So this project is, the TodoMVC challenge is tracking bugs, feeding them back into AssetGraph, because we're treating defects as bugs in AssetGraph, not in the source code of the application. And our current status of the TodoMVC challenge is that we are actually able to build 80% of all the TodoMVC applications in the TodoMVC project. I think that's quite impressive. There are some percentages left. Some of them will probably never be met because the problem with AssetGraph is that it has to understand all your code, and a lot of these are using non-standard syntaxes for module loading, basically. So where you would normally use script includes or require.js or something that is standardized, these do not. So we haven't implemented support for Yahoo module loader or all of the others that are there. It's clearly annotated in the challenge which ones we're not going to support unless they actually submit a pull request to us. I think that's pretty good. I think 80% is a success. I think it's good enough for a lot of people to be able to use this out of the box without encountering any problems. On the other hand, when you create a new build system, people will go ahead and say, isn't this just yet another build system? And I think it's a fair question to ask because this is the build systems space is becoming just as popular as the MVC framework space these days. Everybody has their own, everybody's thinking about their own, or actually building it and open sourcing it. So we have to somehow give an argument for this being good enough for open sourcing it, which it has been for 5 years, by the way. I think it is. I think it brings something new and valuable to the space because it has a very simple rule that says if you just make it work in the browser, AssetGraph gives you the guarantee that it will be able to build it for you. That's a very simple interface which gives you a very clean way of doing your development iteration loop and then basically moving all the concerns of a build system much closer to your deployment step. So AssetGraph, in short, we are AssetGraph on Twitter. We have a website. It's just a splash page, but it links to our GitHub page. We're on Freenode. It's implemented in Node.js. The license is BSD, and the first commit is from December 23rd, 2010. That's actually half a year before Grunt was released. It's just taken us quite a while to figure out that this might be useful to other people than ourselves. So it is currently in use by one.com. I don't know if you can read this, the logo leftmost. That's the company that I was working at the moment where we conceived of this idea. One.com is building every web application that they're making with this tool. They're actually also building all of their customer websites. It's a web hosting company. So they're building all their customer websites, which are generated through their Visivic tool using AssetGraph, which plays really, really well with their whole varnish cache setup. It's actually quite impressive. It is currently in use by TypeScript. So if you go to practice.typescript.com, you will see a website which is actually built by AssetGraph. And it is also used by Falcon Social. It's a startup in Copenhagen. Incidentally, I worked there for half a year. So now they're using AssetGraph Builder. That was basically all I wanted to say, but I thought that since I have like 5 minutes left, I might do a few demos to show you how these tools actually work, how easy they actually are to use. So I thought that I would, oh yeah, I talked too fast apparently. I would show you AssetGraph Builder first of all. So I will build, I will do the same workflow that I do when I build the TodoMVC application for the TodoMVC challenge, which is basically running a binary that is exposed by build production, by AssetGraph Builder. The binary is called build production. This is a route to the jQuery, a path to the jQuery application, and this is the output directory that I want AssetGraph Builder to build to. So, oh, excuse me. This is probably too small for you to see. Is that better? Go away, Passy. Okay, so we paste this magical command line in, and it will go and read the application from the disk, and it gives you a lot of logging output. AssetGraph Builder is pretty much a kitchen sink of build tools. It does all sorts of stuff. It runs ngmean for AngularJS application. It deals with knockout templates. So it's basically trying to cover all bases at once, which means that this should be the thing that you could just apply. And now this application should have been built into the demo directory. And what you see here is there is an index file and there is a static directory. We're putting all the statically built assets which are named with the MD5 sum of their content for far future expires cache. We put that into static so you can serve everything that is in static with this far future expires cache. If I open a static web server in this site, and I think I should maybe just go out of full screen, there we go. Then I can open the application that I just built using AssetGraph Builder. And it is obviously very functional. There you go. So that is one of the demos. I will skip the rest because some of them take some time. I have a tool called AssetWiz. This basically takes any website you point it at. It creates a D3 force-directed graph, which is a representation of the AssetGraph model that you have in memory. It's very good for debugging and for impressing your colleagues when you have this graph of all your front-end assets. I have a project called Content Secure, which tries to do a static analysis of all the code that is in the AssetGraph and tries to figure out what are your outgoing relations out of your page, and then try to give you some hints to what your content security policy might be based on that. This is a project. Xpush is a project I'm really looking forward to diving more into. It's fairly new. The idea is that it is an Express middleware that is using Node Speedy, and it is leveraging the Speedy push method. And that's really exciting because the only thing that we need on a server in order to use Speedy push correctly is actually the knowledge of the dependencies between the files. And that is a thing that AssetGraph can actually provide you directly. So what Xpush does is it starts a server and then it automatically populates the website that is in the web root. And it is basically a memcache server. So when your server requests, it will traverse the dependency graph and it will automatically push all the assets that it knows is a part of the dependency graph to the browser before the browser even knows it needs it. This offsets a ton of latency, which means that in the future, I'm pretty sure that using speedy push could actually completely remove the need for bundling altogether. I think it's that powerful. I'm hoping this will be a part of the future of web development, killing off the build system because it's simply too much hassle. It's too annoying. Those are some other things that I'm working on at the moment. So that is the no build system. It is a build system that you should not worry about in development. Actually, the only thing you should worry about is making your stuff work in the browser. Thank you for listening.